So next in the electrochemistry, the electrochemical cell-based concepts. We are going to discuss previous on Nernst equation, EMF, electrode potential, galvanic cell, voltaic cell, electrolytic cell, difference between electrolytic cell and galvanic cells. So these are the differences. Primary cell. A primary cell is a special type of electrochemical cell which reaction cannot be reversed, and the identities of the anode and cathode therefore fixed. The anode is always negative electrode. The cell can be discharged but not recharged. It's not a rechargeable. It's not in the equilibrium. It's not in the reversible. So only one part we can do it. So the primary cell is only one-way reaction is happening. Secondary cell is one in which the electrochemical reactions is reversible, and the cell being charged, the anode becomes the positive and cathode is negative electrode. This is also the case the electrolytic cell. When the cell being is discharged, it behaves like primary cell, which anode has the negative and cathode will be the positive electrode. Example, rechargeable batteries. And reference electrode. Reference electrode is an electrode which has a stable and well-known electrode potential. There are many ways reference electrodes are used. The simplest is reference electrode used as a half cell to build electrochemical cell. This allows the potential of the other half cell to be determined. So common reference electrode, standard hydrogen electrode SHE, normal hydrogen electrode NHE, saturated columnar electrode SCE. So these are the electrodes can be used as a reference electrode in the electrochemical cell or parts. So in the secondary cell, chemical reaction is reversible. In the primary cell, it's not reversible. So first charging position of it will happen. Anode will be the positive and cathode will be the negative. Once the discharging is going to happen, it will act as a primary battery. It will be in the opposite of previous one. So anode will be the negative and cathode will be the positive electrode. Example, rechargeable batteries. All the rechargeable batteries, it will be the secondary cell. So example, the potentiometric titration is a technique similar to direct the titration of redox reaction. No indicator used. To do this, two electrodes are used, an indicator electrode and reference electrode. The indicator electrode forms an electrochemical half cell with the interested ions in the test solution. The reference electrode forms other half cell holding the consistent of electrode potential. And buffer solution is an aqueous solution consisting of mixture of weak acid and its conjugate base or weak base and its conjugate acid. Its pH changes very little when a small amount of strong acid or base is added to it. They use to prevent the change in the pH solution. Buffer solutions are used as means keeping pH at nearly constant value. Wide variety of chemical application. One example buffer solution for nature is the blood. So Henderson-Hasselbalch equation. In the chemistry, Henderson-Hasselbalch equation is useful estimating the pH of a buffer solution and finding the equilibrium pH in acid-base reaction, the equation is given by pH equal to pKa plus log 10 A minus divided by HA, where HA is the molar concentration of undissociated weak acids and A minus is the molar concentration of acids conjugate base, and pK equal to log Ka, where Ka is the acid dissociation constant. In the concentration cells, electrolytic concentration cell, where the electrodes are identical, they simply differ in the concentration of electrolytic half cell. So the concentration cell is an electrochemical cell where the two electrodes are the same material. The electrolytes and the two half cells involve the same ions, but electrolyte concentration different in the two half cells. For example, electrochemical cell where copper electrode submerged into two copper sulfate solution, concentration differed 0.05 molar to 2 molar connected through sample. This type of cell with generate potential can be predicted by Nernst equation. Both electrodes undergo the same chemistry. So copper 2 plus it will get reduced at the anode. Concentration of cell, electrode themselves different composition. This may be due to the different porosity of gases involved in the electrode reactions. H plus H plus H2 gas electrode, different composition of metal amalgams in the electrode materials. Thank you.